Hey guys, now we're going to talk about how to do map 2 on our lab. So map 2, if you go to the next page, it looks very similar to what we've done in the previous video, where we already have station 1, we know how far away the earthquake is from station 1, we just need to figure out how far away the earthquake is from station 2 and station 3 right here, and that way we can figure out how far away the earthquake is, or exactly where the earthquake is. Let's start with our data table, which looks like this, and we're going to start this video with calculating how far away the earthquake is for station 2. So I'm already given the P wave arrival time, the S wave arrival time. I'm given the time difference. I'm going to use this time difference to figure out how far away the earthquake is. And for that, I'm going to be needing my reference table and a piece of scrap paper. So if my difference is 4 minutes and 10 seconds, I'm going to take my scrap paper. This is the page I'm using, by the way, page 11 of my reference table. I'm going to be using my scrap paper on the y-axis, and I'm going to be measuring 4 minutes and 10 seconds. So I'm always going to mark a line at 0 on my y-axis, and I'm going to mark another line at 4 minutes and 10 seconds, which should be somewhere right here. This is 4 minutes, this is 4 minutes 20 seconds, 4 minutes and 10 seconds must be somewhere in between. Now I'm going to take my scrap paper and move it up until both these marks match up with my S wave and my P wave curve. And it looks like my mark should align somewhere over here. As you can see, my marks are connecting with my P and S wave curves. If I want to figure out what distance that is, I'm just going to go down to my x-axis over here, and it looks like the distance is 2,000, 2,200, 400, 600, 2,700 kilometers. Let's write that down for station 2's distance to the epicenter, 2,700 kilometers. Now I need to figure out the distance from the epicenter for station 3, and for that I need to use the data that's given to me for station 3. Let's find out when the P wave arrived first. Remember, each small increment is 20 seconds. The bigger increments are 1 minute. So this is 3 hours 20 minutes, 3 hours 21 minutes. This must be 3 hours 22 minutes. The P wave arrived at 3 hours 22 minutes and 0 seconds. Now to figure out when the S wave arrived, I'm going to go back to this picture right here, and this is where the S wave arrived. This is 3 hours 25 minutes, 3 hours 26 minutes, 3 hours 26 minutes and 20 seconds, 3 hours 26 minutes and 40 seconds. This must be 3 hours 26 minutes and 50 seconds. So this is 3 hours 26 minutes and 50 seconds. Now if I subtract the bigger number minus smaller number, I can get the difference in arrival time. Let's do that up here. 3 hours 26 minutes 50 seconds minus 3 hours 22 minutes and 0 seconds gives me 0 hours 4 minutes and 50 seconds, and that must be my difference in arrival time. Let's write that down. 4 minutes and 50 seconds. Now I can use this difference in arrival time to find the distance to my epicenter by using my scrap paper and my reference table. So I have my scrap paper right here, and I'm always going to go to my y-axis. I'm going to mark a line at 0 and another line at 4 minutes and 50 seconds. Here's 4 minutes. Here's 4 minutes and 50 seconds. So this is 4 minutes 20 seconds, 4 minutes 40 seconds, 4 minutes and 50 seconds must be somewhere here. Now I'm going to move my marks, my scrap paper, until my marks connect with the P and S wave curves. And it looks like they would do that somewhere over here. So now I just need to figure out what distance this is. And I'm going to go to my x-axis to figure out this distance. And it looks like that distance is at 3,000, 3,100, 3,000, 3,200, sorry. And this must be 3,300. right here. So my distance to my epicenter is 3,300 kilometers. Okay, now try this, pause the video, try station 2 and station 3 on your lab, and then on the next video I'll show you how to do the map part.